My name's Ray Poynter, and I'm going to tell you 10 things you need to know as an introduction to machine learning for insight professionals. Here are the 10 things, and we'll cover those one by one. The first is that supervised machine learning needs a training set. What do I mean by that? So we have a set of data and we have a set of outputs. So in market research, this might be that we have 5,000 open-ended comments and we have the results of somebody coding them or a team of people coding them. And we can then use a machine learning algorithm to look at that data and to find a method of mapping all of those training inputs to the outputs. The reason we do that is we then have a trained algorithm and we can take a much larger set of data, perhaps 100,000 or 1,000,000 open-ended comments, and we can produce the outputs that belong to that. So we have a fixed input, the training, we have the outputs, we create a training algorithm, and then we can use that trained algorithm on future data. So how does that work? Here's a little example with a very simple set of numbers. So maybe we have the number 1 and the coder codes that as an odd number. We have a number 2 and it's been coded as even. 1 odd, 3 odd, 2 even. So then the algorithm looks at that and it says, right, there are 2 outcomes, odd and even. And every time there is a 1 and a 3, then the result is odd, and every time the result is a 2, then the result is even. And after a certain number of repetitions, it would be able to make a pattern that did that. Now, if we give it some more training data, and this time we see that 1 is odd, 4 is even, but now there is a miscode or an error, 1 is even, and then 1 is odd. Now we still have 2 outcomes, odd and even. We know there are 3 results in odd, 2 and 4 both result in even, but we now have to say that 1 usually results in odd. And so the learning algorithm will have to find some way of either mostly allocating 1s to be odd, or of allocating all 1s to being odd and assuming that that is a mistake in the process. If we had some more data, some more training data, 14 is even, 13 odd, 24 even, 301 odd, we don't really know which way the model is going to be built. There are 2 quite likely ways. One is that the machine will learn that 1, 3, 13, and 301 are probably odd, and that 2, 4, 14, and 24 are even. Or it may learn that it only needs to look at the last digit. So numbers ending in 1 or 3 are probably odd, numbers ending in 2 or 4 are even. Now, this brings us to the second point about supervised learning. You usually don't know how the model works because with this particular set of data, it could have generated a model like A, it could have generated a model like B, or it may have made some combination. So it may have said, well, if you've got data that matches A, use that, but if you haven't, use the rule implied by B. And as we will see in some later cases, not knowing how the model works is important. Third case, third point, brand new inputs confuse the model. So if now we get a 7, the system is either going to tell you that it can't allocate it, that's a really good result, or it will give you some sort of answer. Maybe the first thing in the list, maybe the last thing in the list. But when we haven't used a piece of information in the training set, we can't get the model to allocate it. Now, here's another example about when the world changes, the model can fail. So, simple example, talk about the Utopia Island and ferry passengers. And if you look how many passengers there are on sunny days, it's 100 or 120, 110. On cloudy days, it's 50 or it's 45. And on rainy days, it's 10 or 15 people. So the machine learning program can identify that the weather impacts the number of passengers we're going to get. We could probably improve that model by putting in the day of the week or by putting in the season. And this model runs really well, and we can use it to predict how many staff we need and how much food we need for the snack bar and so on. And then all of a sudden, the observed data changes, 30 and 25 for a sunny day. What's happened? We go to visit the island and we find that a bridge has been built. When the world changes, a new product is launched, regulation changes, the marketing changes, the climate of the discussion changes, the model will often stop working. We also have to make sure that the outputs are defined by the input. So here we have some data and we're trying to work out whether or not people are likely to prefer Coke, Pepsi, or neither. And we've got some simple demographics like male, 33 years old, single. And the problem is that whether or not you like Pepsi or Coke or neither is not determined very much by your gender, your age, or your marital status. So if we try to build a model, it won't be particularly predictive. We need training data and inputs that are actually related to the outputs. The training set has to be big enough. So if you look at these sort of questions here, we've got some open ends from people traveling on the Utopia ferry, and we have coded them with a human on the right-hand side. I liked the boat ride, the scenery was great, positive. A, B, C, D, H, neither positive nor negative nor neutral, it's not applicable. The cliffs were enormous, positive. The queues were enormous, negative. In order to interpret that data, we are likely to use a two-step approach. First of all, an algorithm that can interpret open text data, and then we're going to need a training set of 1,000 to 5,000 cases coded by a human. The more complex the data, the bigger the training data set needs to be. I'm talking to some data scientists about a project at the moment, and they won't consider a training set of less than 100,000. And in market research, we almost never get a training set as large as that. So the training set has to be big enough. That means we can often do these sorts of things. We can code open ends with a training set of 1,000 to 5,000. If the open ends relate to a tracking project, it's even better. We can link stimuli to predicted share after maybe 1,000 tests where we're looking at how the page is laid out, how the packaging is laid out. Or we can link surveys to bad response patterns. This sort of pattern indicates they're a speeder. This sort of pattern indicates that they're not trying very hard. We have more problems when we're trying to turn data reports into automated outputs, because really we'd need 1,000 similar reports where the brief was the same, the scales were the same, the category and the industry were similar enough that we could do that. We'd like to turn research briefs into a machine learning output, but again, we'd need 1,000 times or more where the client has sent us a very similar brief. Or linking survey responses to market outcomes. Again, we'd need a benchmark with 1,000 cases for that market, for that category, with this pattern of responses. And frequently in the market research world, we just don't have enough cases. Machine learning can embody bias. So here's an example where we're looking at who's getting interviews. A male average candidate gets an interview. A male poor candidate gets rejected. A female excellent candidate gets an interview. Female poor rejected. Female average rejected. Male excellent gets an interview. Male average gets an interview. Female average gets rejected. The data learns that if you're male and excellent, you get an interview. If you're male and average, you get an interview. If you're female and excellent, you get an interview, otherwise reject. This is what happened at Amazon, why they had to, in 2018, scrap their AI hiring system, because it had learned what the company did. And not in every single case, but systematically, men and women of equal merit did not get an equal chance of being interviewed. The software looked at it and hard-coded it. And because you don't know how the model works, it takes a long time for you to find out that actually your AI is biased. But let's jump to unsupervised machine learning. The most important thing to remember is this is not like supervised machine learning. Indeed, there isn't any machine learning really in there. We don't have a training set, just real data. The object is to find patterns in the data, and it's very much directed and evaluated by the user of the software. So we might have a bunch of data and we say to it, find me some patterns, find me 3 patterns. And then we think to ourselves, that is just k-means clustering. Yes, ordinary k-means clustering is a simple example of unsupervised machine learning. It can go a lot further, but in principle it's the same, and we can use a side-by-side analysis. When we do cluster analysis, we specify the variables, which algorithm are we going to use, how many clusters do we want to find, what the criteria for clustering is, and then we check them with the human, and we'll rerun it if we don't like the results. With topic modeling, with text, you specify the text that's going to be used, the algorithm. Are we going to use natural language processing or a bag of words? What sort of stemming are we going to use? We're going to pick the number of topics. We're going to give it the criterion for clustering, and we're going to check at the end, does it make sense? And if it doesn't, we're going to run it with different parameters. So that's very much the investigative process we use with unsupervised learning. Intelligent interviews or adaptive interviews apply algorithms and or a lookup list. So here's a very simple one. Do you prefer A or B? And we'll code the winner as W1. Do you prefer C or D? We'll code the winner as W2. And then we will ask the question, do you prefer W1 or W2? And that will seem adaptive and it will seem intelligent to the respondent. What did you like about the advert? This is a more complicated version of that. If the response includes a word that begins with fruit, or a word that begins with apple, or a word that begins with orange, then probe. We're now seeing systems that can use things like Alexa. So that same adaptive algorithmic approach can be applied to that. What did you like about the advert? Interpret the voice response. If the response includes words beginning with fruit, apple, or orange, then probe. 5 key links is my final point. So it's a little bit of a cheat, really, this 10th one, because it's 5 key links. Supervised machine learning. It's where we have common tasks where the outcome is known and defined. Unsupervised machine learning is where we're asking the computer to suggest possible solutions and patterns in the data. Expert systems, where we can define what we do, for example, in project design, data cleaning, project management. Adaptive intelligence surveys are where we can use an algorithm to guide those adaptations. And leveraging a system built with AI is by far and away the most common thing we do in market research and insights. We're using systems that were built with AI, even though we're not running new AI itself. So we're using text analysis, we're using automatic voice to text, translation software, and so on. So I hope that's been useful, and I look forward to your questions. We hope that you enjoyed that NewMR webinar and ideally found it both interesting and useful. We love producing all of these webinars for the research and the insights industry, but it does cost money. We have licensors, we have editing, we have tech team, and so on to provide for. And almost all of that cost is met by the NewMR sponsors. So we'd like to give a really big thank you to all of these people you see here on the page, the people who make it possible for us to bring all of these webinars and the blogs and all the rest of it to you. You can say thank you to these people too by visiting their website or asking for a quote the next time you're looking for one of their services. And when you do, please do mention that you saw that they were sponsors of NewMR. That will help give them the confidence to continue being sponsors of NewMR and its services, webinars, blogs, and so on. You could also become a sponsor of NewMR if you wanted. If you would like to find out about the sorts of packages we have, please contact us. And you can find out more about what we do and how to contact us at the newmr.org website.